Welcome back to today's session. In the previous sessions, we learned two different methods of computing IBFS, that is the initial basic feasible solution for the transportation problem. First amongst them was Northwest Corner Rule or NWCR. The second one being least cost method. Today, we will be learning Vogel's approximation method, or this method is also called the penalty method because we would be finding the penalties for the rows and the columns based on which we will be making the transportation allocations. Fine. So shall we start off with the Vogel's approximation method? So first we will look into the steps involved in solving a transportation problem using Vogel's approximation method. So step one, find the penalty, which is the difference between the smallest and the next smallest in each row and each column. So for every row and every column, what we have to do is identify the least cost and the next least cost. We will have to find out the difference between the least and the next least cost, and that will be the penalty for the corresponding row or the column. Step 2, among the penalties as found in step 1, choose the maximum penalty. So out of all the row penalties and the column penalties you have computed, whichever is the highest penalty, it can be either row or the column, that doesn't matter. So identify the maximum penalty. If there is a tie in the maximum penalty, choose any one arbitrarily. Let me say if two rows had the penalty, maximum penalty, let me say 5. So row 1 also had 5 as penalty and row 3 also had 5 as penalty. Then what to do? You will randomly pick any one of the row, right? If there is a tie in the maximum penalty, choose any one arbitrarily. Then after choosing the maximum penalty, what we are supposed to do? That is in step 3. In the selected row or column, so wherever you had maximum penalty, that particular row or column, as by step 2, find the cell having the least cost. So in that maximum penalty row or the column, see which is the least cost. Allocate to this cell as much as possible depending on the capacity and the requirement. So compare the capacity and the requirement, whichever is minimum, that much allocation has to be done in the least cost of the highest penalty row or column. Okay. Then step 4, delete the row or column which is fully satisfied. If the capacity or the requirement is completely satisfied, then that particular row or column will be crossed off. Again, compute the column and row penalties for the reduced transportation table. See, after crossing off a row or a column, the transportation cost matrix will obviously change. So for that reduced cost matrix, we are supposed to compute the row penalties and column penalties again. And then go to step 2. Repeat the procedure until all the supply and requirements supply and demand requirements are satisfied. Okay. So one important note that we need to observe here is when the penalties cannot be computed, that is, let me say all rows are exhaust or all columns are exhaust, but still the problem has not come to an end. What are we supposed to do? For that reduced cost matrix that you are remaining with, you continue solving it with least cost method. Okay, you are supposed to continue with least cost method. So when you listen to the steps, you might have partially understood the process of solving a problem, but you will be able to understand it better when you actually consider a problem and try to solve it. So we will consider an example problem. I will take the same problems that we had considered for northwest corner rule and least cost method. Same problem I'll take. So the first problem is obtain the IBFS for the transportation problem with VAM whose cost matrix is as given below. This was the cost matrix. So this is balanced. We have already checked it because we took the same problem in northwest corner rule and least cost method. We know that the totals will match and it is 34. Okay. So that has been written here. Since summation AI and summation BJ is equal to 34, the problem is balanced transportation problem. So I'll put one additional column and one additional row for row penalty and column penalty. So what are the row penalties? Identify the least cost in this row. Least cost is 2. Next least cost is 4. What is the difference between 2 and 4? 4 minus 2 is 2. So that will be the penalty for this row. Coming to this row, 1 is least, next least is 3. 3 minus 1, 2. Then here, least is 4, next least is 5, difference is 1. Least is 1, next least is 2, difference is 1. Column wise, in this column, least is 1, next least is 2, difference is 1. Least is 3, next least is 4, difference is 1. Least is 1, next least is 2, difference is 1. So which is the highest penalty now? 2. We have 2 in 2 different rows. Row 1 also has 2, row 2 also has 2. Right? The algorithm tells us to choose anyone arbitrarily. But my logic says, my method says, look into this row with the highest penalty. Least cost is 2. In this row, least cost is 1. So I will pick this row and this cell. Okay, I will select this row and least cost in that row is 1. So I will make an allocation in this cell. So what is the allocation that you can make? Supply is 8, demand is 18. So you can satisfy 8. So I will allocate 8 units here in 2, 3. I make an allocation of 8 units. So in 2, 3, 8 units. So this supply becomes a 0 and this became a 10. Okay. Now recompute the penalties. This row is already gone. So I need not compute the row penalty for this row. For the remaining rows, 2 and 4, difference is 2. 5 and 4, difference is 1. 1 and 2, difference is 1. 1 and 2, difference is 1. 3 and 4, difference is 2. Oh, sorry, not 3 and 4. Oh, this row is already gone, right? This row is gone. 1 minute. First, let me cancel it. Color. Okay. This row is gone. So now for the remaining matrix, I'll have to calculate. Uh, 2 and 4, difference is 2. 4 and 5, difference is 1. 1 and 2, difference is 1. 1 and 2, difference is 1. 4 and 6, difference is 2. 2 and 4, difference is 2. So I have three places where I have 2 now. So you can pick any one arbitrarily. So in this, minimum cost is 2. In this, minimum cost is 4. In this, minimum cost is 2. So both 2 are there. Now I'll pick arbitrarily. So let me say I selected this. So how much I can satisfy? Demand is 10. Supply is 14. So I can satisfy 10 here. So make an allocation of 10. So here 10 minus 10 becomes 0. Here 14 minus 10 becomes 4. So this column gets cancelled now. So I made an allocation at 4, 3 with 10. 4, 3, 10. Fine. So this row is already gone. And now this column is also gone. Now the remaining matrix is 2, 7, 5, 4, 1, 6. Find out the penalties. 2, 7 difference is 5. 5, 4 difference is 1. 1, 6 difference is 5. Here 1 and 2 difference is 1. 4 and 6 difference is 2. So the highest penalty is 5. I have it in two places. One is here and the other one is here. So if at all I pick this, my least cost will be 2. If at all I pick this, my least cost will be 1. So I would prefer this. So I make an allocation in this cell. How much I can make? Supply is 4, demand is 7. So I can satisfy 4. So I make an allocation at 4, 1 with 4 units. 4, 1 with 4 units. Now this row is gone. This row is gone. And this column is gone. So what is the matrix that I'm left out with? 2, 7, 5, 4. So 2, 7, the penalty is 5. 5, 4, penalty is 1. 5 and 2, penalty is 3. 7 and 4, penalty is 3. So now no choice because the highest penalty is 5 and the least cost in it is 2. So I'm supposed to make an allocation here. So how much is the allocation that you can make? I was left out with demand 3 and supply 5. So which is the minimum out of the two? 3. So I will make an allocation of 3 units here. So here demand becomes 3 minus 3, 0. Supply becomes 5 minus 3, 2. Okay. So I make an allocation at 1, 1 with 3 units. 1, 1 with 3 units. So this column is gone. This column is gone. This row is gone. And this row is gone. Now you cannot find out any row penalties because to find the difference I need to have 2. I don't have 2 elements at all. There is a single element. So row penalty cannot be computed. Column penalty can be calculated because I have 7 and 4 as an option. So 7 and 4 difference is 3. So the column penalty is 3. So when the column penalty is 3, I am supposed to pick this. Which is the least cost out of the two? 4. So here I am supposed to make an allocation. How much I can make? Supply is 7, demand is 9. So minimum out of the two is 7. So I can make an allocation of 7 units here. So the supply becomes 7 minus 7, 0. Demand becomes 9 minus 7, 2. So I make an allocation at 3, 2 with 7 units. 3, 2, 7 units. So this row was already gone. This row is also gone. This row is also gone. Columns, this column was gone and this column was gone. Now the only unit left out or the only cell left out is 7. So when the last cell is left out, I have told you the supply and demand should match. See, supply I have 2, demand I have 2. So I can satisfy 2 so that the row and the column will be eliminated. Okay? Any doubt with this? So I made an allocation of 2 at 1, 2. At 1, 2 I made 2 units allocation. Now what is the next step? Compute the total transportation cost TTC. So it is 3 into 2 plus 2 into 7 plus 8 into 1 plus 7 into 4 plus 4 into 1 plus 10 into 2. So 3 twos are 6, 2 sevens are 14, 8 ones are 8, 7 fours are 28, 4 ones are 4, 10 twos are 20. So it is 6 plus 14 plus 8 plus 28 plus 4 plus 20. 16 plus 4, 20. 20 plus 8, 28. 28 plus 28, 56. 56 plus 4, 60. 60 plus 20, 80. So we got the TTC to be 80. So when I solved the same problem using LCM, I had got an answer of 83. Same problem with NWCR, I had got 102. So one thing that you observe here is WAM is giving you a better solution than NWCR and LCM. Will it hold good for all the problems? Let us have a look by taking another problem. So this is the second problem that I used to take all the time. So 6415, 8927, 4362 with supplies 14, 16, 5 and demand 6, 10, 15, 4. So we have already seen that the problem is balanced. When I add up, I get 35 on both sides. So that is what has been written here. Since summation AI is equal to summation Bj is equal to 35, the problem is a balanced transportation problem. So put an additional column and an additional row for computing row penalty and column penalty. So what is the penalty here? Least cost is 1, next least is 4, difference is 3. Least cost is 2, next least is 7, difference is 5. Least cost is 2, next least is 3, difference is 1. Here 4, 6, difference 2, 3, 4, difference 1, 1, 2, difference 1, 2, 5, difference is 3. So there is no confusion at all. So maximum penalty is 5. I am supposed to pick this row. In this row, which is the least cost, 2. So I am supposed to make an allocation here. So how much allocation will be made? Demand is 15, supply is 16. So I can satisfy 15. So when I supply 15 here, so the demand becomes 15 minus 15, 0. Supply becomes 16 minus 15, 1. Okay. So I make an allocation at 2, 3 with 15. 2, 3 with 15. So this column got cancelled, got removed. Recompute the penalties. Least cost is 4, next least is 5, difference is 1. 7, 8, difference 1. 2, 3, difference is 1. 4, 6, difference is 2. 3, 4, difference is 1. 2, 5, difference is 3. Once again, here it is a clear-cut case. So the highest penalty is 3. In this column, look for the least cost. Least cost is 2. So I'm supposed to make an allocation here. How much I'll make? Supply is 5, demand is 4. So I can satisfy 4. So the demand becomes 4 minus 4, 0. Supply becomes 5 minus 4, 1. Okay. So I'm making an allocation at 3, 4 with 4 units. 3, 4 with 4 units. So this column is gone and this column also is gone. Now recompute the penalties. So 6 and 4, difference is 2. 8 and 9, difference is 1. 4 and 3, difference is 1. Here 4 and 6, difference is 2. 3 and 4, difference is 1. So once again, there is a tie. I have 2 here and 2 here. So the least cost when I go here is 4. The least cost when I go here is also 4. Arbitrarily you can pick any. So I will pick here. Okay. So I make an allocation of 1 unit. Why? Because supply is 1, demand is 6, minimum is 1. I make an allocation of 1 here. So demand becomes 6 minus 1, 5, and supply becomes 1 minus 1, 0. So I make an allocation at 3, 1 with 1 unit. 3, 1 with 1 unit. So this column is gone. This column is also gone. Now this row is gone. Now recompute penalties. 6 and 4, penalty is 2. 8 and 9, penalty is 1. 8 and 6, penalty is 2. 9 and 4, penalty is 5. So once again, clear-cut case. Highest penalty is 5. Least cost in the column is 4. So I'm supposed to make an allocation here. How much you will make? Supply is 14. Demand is 10. So I can satisfy 10 here. So demand becomes 10 minus 10, 0. And the supply becomes 14 minus 10, 4. So this allocation that I make is at 1, 2 with 10 units. 1, 2, 10 units. So this column was gone. This column was gone. This row was gone. Now newly this column is also gone. So now you cannot compute row penalties because you have left out with only one value. So obviously you are supposed to take column penalties. So 6 and 8, difference is 2. So consider this penalty. Check which is the least cost in the column. 6 is the least cost. So how much you can satisfy? Demand is 5, supply is 4. So you can satisfy 4 here. So if at all I make an allocation of 4, supply becomes 4 minus 4, 0. Demand becomes 5 minus 4, 1. So I make an allocation at 1, 1 with 4 units. 1, 1, 4 units. This column gone, this column gone, this column gone, this row was gone. Okay. Now this row also went. Now I am left out with only one cell. Whenever a single cell is left out, my supply and demand will match. If at all I have solved the problem correctly, the supply and the demand will match. See, supply is 1, demand is 1. So satisfy 1 unit here so that the row also gets crossed off, the column also gets crossed off. The problem is solved. So I made an allocation at 2, 1 with 1 units. 2, 1 with 1 units. What is the next task? Total transportation cost, TTC. So TTC will be 4 into 6 plus 10 into 4 plus 1 into 8 plus 15 into 2 plus 1 into 4 plus 4 into 2. So I'll get 4 6 are 24, 10 4s are 40, 1 8s are 8, 15 2s are 30, 1 4s are 4, 4 2s are 8. So I get 24 plus 40 plus 8 plus 30 plus 4 plus 8. So 24 plus 40 is 64. 64 plus 8 is 72. 72 plus 30 is 102. 102 plus 4 is 106. 106 plus 8 is 114. So I get the transportation cost, total transportation cost to be 114 units. So when I solved the same problem using LCM, I got 156. When I solved using NWCR, I got 128. Now also it shows WAM gives you a better solution than northwest corner rule and least cost method, right? So the assumptions is, or the concept of WAM is designed in such a way that it always gives you better solution than northwest corner rule and least cost method. Hope you have understood the method. The concept is very simple. Only thing is you have to be very careful when you are calculating the penalties, and whenever you have penalties, choosing the least cost you should do properly. If at all you don't do it properly, if at all you miss out on any cell, then you will arrive at wrong answers. Hope you have understood. Thank you for your patient listening. In the next session, we will be looking into how to handle unbalanced problem and maximization case problems. Till then, have a nice time, enjoy, be home, and be safe. Thank you.